Hello, and welcome to Math 120. My name is Watkins, and I'm your online instructor for the course this semester. The videos are designed to augment the lecture notes that you will find on Blackboard. So if you go to our course on Blackboard and look under each of the individual modules, you'll find some lecture notes that are PDFs. And what we're going to do is go over those lecture notes. In addition, we'll work through the examples that are on each of those lecture notes. Each section has been divided up into several different videos. That way it's not a huge chunk of information being thrown at you all at once. And of course, because they're videos on YouTube, you can stop, go back to the beginning, go over another example, look through an example again, all of that kind of stuff. So today we're going to start with section 1.4. Yes, our course starts in section 1.4. We are going to assume that you have the background knowledge in the first three sections. You're more than welcome to look them over in the e-text and also on the online homework system. So what we're going to work on today in section 1.4 is we're going to solve, this is section 1.4, part 1. We're going to work on solving different types of equations. Specifically, this part, we're going to solve radical equations. We're going to focus on solving a variety of equations. In this section, we work on finding the real solutions. So we're not going to look at anything that involves the square root of a negative number, only real solutions. We do assume that you can already factor and use the quadratic formula. So what you see on your handout, if you're looking at that, are the steps involved in solving a radical equation. Our very first step is to always isolate the radical term on one side. Then you're going to raise both sides to the same power. This should eliminate the radical. However, in step 3, if you still have a radical, go ahead and repeat steps 1 and 2. And we'll do examples of each of these in just a second. You're going to solve that resulting equation. And because you're dealing with radicals, which have domain issues, you can't take the square root of a negative number, you always need to check those answers to make sure they're working and that you don't have any extraneous solutions. So let's jump in and do an example. In the example we're going to solve, and we'll reiterate those steps as we go through and do these. This is example 1. We want to solve the equation, the square root of 2t minus 1 is equal to 1. So our very first step says to isolate the radical on one side. Well, this radical is already by itself, so I don't need to do step 1. Step 2 says to raise both sides to the same power. So what we're going to do is eliminate the square root by squaring both sides. And if we do that, the square undoes the square root, giving us 2t minus 1. On the right side, we get 1 squared, which is just 1. Now radical is left, so we can proceed to solve from here. This is a linear equation. There are no exponents, so we just need to isolate the t. So go ahead and move that 1 to the other side. We'll have 2t is equal to 2, and we'll divide out the 2. So when it's all said and done, we get a solution of t equal to 1. But we need to check that. Most of the time, you can just verbally check it. We'll write it out just to make sure we don't lose anybody. The original equation said the square root of 2t minus 1 is equal to 1. We're going to replace our t with that 1. So that would give me the square root of 2 times 1 minus 1. And the question is whether or not this is true. So we're really checking to see if this works. So 2 times 1 is 2. Minus 1 is 1. And sure enough, the square root of 1 gives me 1. So it works as a solution. We've solved our first radical equation. Example 2 deals with a cubed root instead of a square root. So does that change the process? Well, a little bit. So in example 2, we have the cubed root of 1 minus 2x, and then minus 3 is equal to 0. So back to our steps. Step 1 said to come in and isolate the radical on one side. So when I'm isolating the radical, what I'm really doing is moving this 3 over to this side because it's much easier to square single terms than it is to square multiple terms on one side. So we're going to move that 3. We'll keep the cubed root of 1 minus 2x on the left. By moving the 3, we'll have it equal to 3. Now we're going to raise both sides to the same power, and here's where the slight difference is. Because it's a cubed root, we'll have to cube both sides. So we're going to raise both sides to the 3rd power this time, and again, that's because it's a cubed root. So this cubing will undo the cubed root and leave me with 1 minus 2x. 3 to the 3rd power is 27. We'll go ahead and solve from here, moving the 1 to this side. We'll get negative 2x is equal to 26. And then we're going to divide out that -2, and we'll get x equals a -13. Now we can check it. So we're asking ourselves whether the cubed root of 1 minus 2 times that -13, and is that equal to 3? So that's really what we're checking. Well, -2 times -13 is a positive 26. 1 plus 26 is going to give me a 27 under the radical. This is the radical. The cubed root of 27, sure enough, is 3. So it works as a solution. It's a good solution. But the only difference here is we did have to isolate first, and we cubed instead of square root. Let's do example 3, a little more complicated. Both of these examples, once you remove the radical, we're left with linear equations. So very easy to solve at this point in your algebra career. Example 3 has a twist. So example 3 says we're going to solve the square root of x minus 1, and that equals x minus 7. So the difference should be apparent in the previous 2 examples. Once we isolated the radical, everything was left or equal to just a single term. This is equal to 2 terms, and that's going to change our approach. We're still going to come in and get rid of the radical because it is isolated. We'll square both sides. So on the left side, the radical, the squaring undoes the radical. On the right side, though, what we really have is x minus 7 times x minus 7. So because this is 2 terms, the x is the first term, the 7 is the second term, we're going to have to FOIL. We did not need to do that in the previous examples because they were single terms. They didn't have that sign separating numbers or things. So when we FOIL this out, we're going to get an x squared. We'll get a minus 7x, a minus 7x, a positive 49. So that's going to give me x minus 1 is equal to x squared minus 14x plus 49. At this point, we have a quadratic equation. What that means is we've got an x squared sitting there. So instead of moving, x to one side and constants to the other, we have to set it equal to 0. So we're going to recognize that because we have an x squared term, that makes it a quadratic. And we need to set equal to 0. So to do that, we're going to move the x to the right side, and we'll move this minus 1 to the right side. We'll subtract the x, we'll add the 1. Subtract the x, add the 1. That's going to give me 0 is equal to x squared minus 15x plus 50. You can go to the quadratic formula, but factoring is always quicker. I always check to see if it factors first because it is quicker. We're looking for factors of 50, 50, that are going to add to 15. So factors of 50 that add to 15 exist. 10 and 5 work. So we get x minus 10 and x minus 5. They're both negative because you're adding to get the middle term. The middle term has a negative sign on it. So both of these factors need that negative sign. Solving each of these, you're really setting the x minus 10 equal to 0 and the x minus 5 equal to 0. Solving them, you'll see x is equal to 10 and x is equal to 5. But we need to check them. So we need to come in and verbally check them. This is where my small whiteboard works against us. I start to run out of room. So let's check the x equal to 10. Here's our check. And we're doing the x equal to 10 first. So we'll go back to the original equation. Does the square root of 10 minus 1 equal 10 minus 7? So I'm replacing both of the x's with the 10 that we think is a solution. Well, 10 minus 1 is 9, square root of 9 is 3. And 10 minus 7 is 3. So the 10 is a solution, it works, it's good. But what about the x equal to 5? Let's check that one. So that would give me the square root of 5 minus 1. And is that equal to 5 minus 7? Well, 5 minus 1 is 4, and the square root of 4 is 2. 5 minus 7 is a negative 2. So the x equal to 5 does not work because the left and right sides are not the same quantity or value. So x equal to 5 is no good. We're going to cross that one out. So the only solution we got was the x equal to 10.